I solved this problem some times ago. Some persons demanded I should draw the shear force and the bending moment diagram. Here is the bending moment diagram and the shear force diagram. Let's go. But before we draw the diagram, let us determine this reaction force at this point, and at this point. So we take this. So summation of upward force is equal to downward force. So that is to say that F1 plus F2 is equal to what? 400 Newton. Let's call this equation 1. Then let's take moment about any point. Let's call this point A, C, and B. Let's take moment about point B. Moment about point B. So if you're taking moment about this point, let's start from here. So algebraic sum of moment about any point is equal to 0. That is to say that F1 multiplied by the perpendicular distance 2 plus 4 is 6 minus 400 multiplied by perpendicular distance for the point where we're taking moment from, which is from here to here, which is 4. This is equal to what? 0. Algebraic sum of moment about any point is 0. So we have here to our F1 now simply becomes F1 is equal to 400 times 4 over what? 6, which is equal to 1600 over 6. So our F1 is equal to 266.67 Newton. So let's substitute F1 into equation 1 for us to have our F2. It simply means that our F2 will be equal to 400. This will come to this other side. F1, which is equal to F2 is equal to 400 minus 266.67. So our F2 eventually becomes 133.33 Newton. So I've gotten our F1 and F2. So having done that, let us now determine the shear force values and the bending moment value. So the shear force at this point, shear force at point A is equal to the value of the reaction force at that point is what? F1, which is 266.67 Newton. Shear force at point C, at this point C, it becomes, to subtract as we proceed, it becomes 266, this the reaction force here minus the next force that you meet, which is 400, which is equals to, okay, we'll have it here, negative 133.33 Newton. So no other force along the line. So we're done with the shear force. Let's go to the bending moment value. Bending moment at point A, bending moment there is 0 Newton meter because there is no perpendicular distance. Then let us go bending moment at point C. At point C, the bending moment becomes the shear force, the value of the reactional force here, 266.67 multiplied by the distance from this point to this point, which is what? 2. So this will give us, this is giving us 533.34 Newton. So we have determined the bending moment and the shear force value. So let's go straight to draw the diagram. So this is the bending moment and the shear force diagram. If this is your first time coming across my video, like this video, share and comment. I love you.